Greetings. Myself Mukunda and I will be presenting a project on Raspberry Pi based handwritten recognition using AML machine learning system designed to run in on Raspberry Pi and Raspberry Pi OS. The goal of this project is simple. When we upload or capture a handwritten digit image, the system predicts the what digit it is. Suppose 0 to 9. The idea is inspired by the MNIST dataset, which contains thousands of images of handwritten digits. Using this, we train a model to recognize similar handwritten patterns in any new input. When a user uploads an image, we pre-process it and feed it into a machine learning model and get the digit prediction as output. The importing part. So, the models we have used here are TensorFlow, Pillow, and IPV widgets. And the process we imported are NumPy for number access, TensorFlow as TF, PIL import image, and Matplotlib for plotting a graph, IP widgets, and IO for bytes. TensorFlow is for building and training our machine learning model. PIL, Python imaging library to load and pre-process images. Matplotlib for visualizing the input image and output prediction. IPY widget to create an interactive file upload button. Bytes IO to handle the image data that we get from the file uploads. Next, loading and preparing the MNIST dataset. So I am here explaining how the stimulation works. So where so in this we use the MNIST dataset which contains labeled images of handwritten digits 0 to 9. Here's the code to load and normalize the data, and we see that it downloads the data from Google API's TensorFlow dataset. So here we see tf.keras. tf.keras.datasets.mnist load data. What does it do? This loads the dataset into training and testing sets. Xtrain 255. We normalize the pixel values to a range between 0 and 1 for better model performance. np.expand dims dimensions. So what does it do? This changes the shape of the dataset to include a channel dimension required by the neural network, since images are typically represented as 3D arrays, right? So next step we do is the building and training the CNN model. So here we build a convolutional neural network, which here is ideal for image recognition tasks. So here's how we define and train our model. Model model is equal to model sequential and stuffs we see here. So what is conv 2D? The convolutional layers extract features like edges, corners, and textures. Max pooling 2D, as we see here, these layers reduce the image dimensions to decrease computational cost. Flatten here, layers.flatten here, converts the 2D feature map to 1D to pass to the fully connected layers. Dense 10, it is the final output layer with 10 neurons, one for each digit 0 to 9. Softmax here. So softmax, this activation function provides the probability distribution over the 10 possible outputs. We compile and train our model. Here, model.compile. We compile here. So, optimizer is equal to Adam, right? So, we use the Adam optimizer for efficient gradient descent. Loss. So, we here, sorry. Yeah, m.compile Adam. Uh, and then we see loss. Sparse categorical cross entropy. What does it mean? This loss function is ideal for multi-class classification problems. Epochs 5 It is the number of times the model will see the entire dataset during training. So and then we save the trained model. So here it runs 5 epochs. That is the number of times the entire dataset is trained. This might take a while, so I'm not going to run this. So model dot save here. The our model is saved as an HDFI file. So what does it mean? Model dot save handwriting model H5. This saves our model in the H5 format. Later we can upload this model to make prediction without retraining it. So that is here. And then the next step is load the trained model. Run this run this when we run this when the model is trained. So we run this and we compile the loaded model. Anyways, what is this for? uh, I guess we have to run every code again. So while this all runs, then we train the dataset here, building the next is building the CNN model and training it. So this might take a while as we are running 5 epochs, right? So while this happens, we will run the others. So we'll learn about the other steps. So we loaded the trained model. This is done when the model is trained. So then the next step is image pre-processing. Hopefully it's done. Not yet. Anyways, uh, we will learn about the pre-process upload handwritten image step. So this is about pre-processing. When a user uploads an image, we need to pre-process it to match the format that our model expects. Here's the pre-processing step function. Def pre-process image. This is our function. You see all these codes about converting it to grayscale, inverting if white background, threshold, converting into PIL image for cropping, resizing into 20 into 20 and pasting it on a 28 canvas, normalizing and reshape. So we saw that image convert L here. Image convert L here converts the image to grayscale. np dot image uh, np dot array image converts the image into numerical array for processing. np dot mean img array is greater than 127. It is it in it inverts the image if the background is dark. And then mm, thumbnail image dot thumbnail. So image dot thumbnail here, uh, it resizes the image into 28 to 20 pixels while maintaining the aspect ratio. New image paste centers the digit in a 28-28 canvas, the required size for our model. So next is predicting the digit from the uploaded image. So it displays the result after prediction. So after pre-processing, the image is passed into the training model for prediction. So we see the function predict image. So it predict image and it predicts through it. So model.predict. What does it do? It predicts the digit based on the input image. np dot ARG extracts the index of the highest probability which corresponds to the predicted digit. PLD.IMShow displays the processed image along with the okay here. So yeah, PLD.IMShow displays the processed image along with the prediction on the screen. And then interactive image uploading the image widget and display prediction, right? So we use an interactive upload image in Google Colab to allow users to upload an image. So the upload widget function we see here, right? So uh, here we see the widgets dot file upload, right? So widgets dot file upload, this creates the upload button. Handle upload handle upload. The handle upload, this function is triggered when an image is uploaded and it processes the image for prediction. And then the applications and real-time use. Hopefully the processing done, then we will be talking about the other things. We are almost there. Epoch 5 of 5 is running now. So while that being done, we will go through the applications and real world use. So this system can be used as an extended to Raspberry Pi OS for practical use cases. You can use a camera model to capture handwritten digits in real time and pre-process them and predict the digit using the trained model. Some practical applications include like education tools for learning to write digits, assistive technology for visually impaired individuals, digit recognition for scanning and entering into forms of service. So we will wait until the box is completely run and then we will see the execution of the program. It's close. So now it will execute the trained data and then we will be saving it. So yes, and the data is run successfully. Now we will save the trained model. That is done. Now we are going to load the trained model. Even that is done now. Then we pre-process the image as we told, and then we upload the image. So here I will upload my image. So I had my handwriting of image 5. So let's see if it predicts. So we see the prediction is 5 as I uploaded the image 5. So what is the conclusion? So in conclusion, this project demonstrates how we can build a human recognition system based on Raspberry Pi in machine learning by leveraging pre-trained models and image pre-processing techniques. We can easily recognize digits with Raspberry Pi compatibility. This can be deployed for real-world applications like education, assistive technology, and automated data entry. So that is it. Thank you for your attention.